Hello and welcome to the August challenge of the Microsoft Excel Collegiate Challenge. My name is David Brown. I'm an Associate Professor of Finance at the University of Arizona and the founder of the MECC. In this month's challenge, we're going to be working on a fantasy football based case. The idea is you're getting some fantasy football data for your league, and you need to clean it up. That way everybody can work on it, analyze it, and get ready for their draft. The challenge here, whether you're into football or not, is to handle messy data. So that's what we're going to be working on, is handling the data and then also being able to look up certain players to figure out their attributes, their points per game, and really kind of analyze how your fantasy football team is going to do this fall. So let's get to it. So you're going to start out by downloading the file from XPrep. Once you download that file, make sure you unblock the macros. You can see the second tab if you need a guide on how to do that. And then you also want to make sure you click on this Enable Content button at the top here, because there are going to be some macros running in the background that make sure the answers are correct. All right, so let's go ahead and tab over to the case questions to see what it is we're doing. All right, so this case, again, is built all around fantasy football. You'll notice that we have input parameters for several questions, and we have some questions that are static. These first 7 questions here aren't going to change no matter what the data is. So they're going to have a set answer. These correct answers over here do not change. However, as we work down, we're going to get to these dynamic questions that are based on a player name. For example, right now it's Logan Thomas. We're going to have a set of players down here as well, and some more parameters that change. All right, our models are going to need to be flexible and dynamic, so when those parameters change, which is going to happen whenever you save the file, your answers in your model are still going to be correct. All right, so we're going to keep that in mind as we work through. We're going to start out, though, by cleaning the data that we're given. All right, so the data that we have is broken down into kickers, defenses, and so-called skill players, or the quarterbacks, running backs, wide receivers, and tight ends. If you're not into football, that's okay. We don't really need to know anything about football to do this. We just need to take the data and clean it up. So we're going to come back to this tab in just a second, but let's just look at those first couple questions so we know where we're going. So for question 1, we're going to try to figure out the number of spaces between the words in the player column data. So let's go look at that and see if we can figure this out. We also want to note that there's a note here that some of the spaces don't really look like spaces, and we'll get to that in just a minute. To start out, we're not going to need all this data, so we can see things better. I'm going to go ahead and hide most of this so we have just a little bit more room to work. All right, and so the goal here is first to figure out how many spaces are in that player's name, or the player name with the position with the team. So what we're going to use is a function called substitute. So we're going to use substitute, where you put in what text you want to substitute from, and then you specify what you want to get rid of. So in this case, I want to get rid of a space. So I just put quote, then a space, and then quote, and I'm going to replace that with 2 quotes with nothing in between. So basically, I'm going to take any spaces and turn them into nothing, effectively removing the spaces. So let's see what that looks like, and we'll zoom in to get a little bit better view. We can see that there still look to be spaces. That's because in Excel there are some characters that are basically not really the space character, but they still look like a space. And if you delve into the depths of this, you can find out there's something called Unicode characters, and you can use car to figure out what a Unicode character is. So number 160 is this non-blank space. So here it looks like a space, and you can see this. If I just concatenate some letters together really quickly, let's just put D and B together for my initials with the character in the middle. It looks like a space, but it's character 160. So what we're going to have to do is, instead of substituting spaces first, let's go ahead and substitute character 160 and make that a legitimate space. So now we want anything that looks like a space in our count for our problem. So now what we've done is we've substituted out those non-blank spaces for real spaces, and now we can actually see how many of them there are. All right, so that's the basic idea of our approach here. And that character 160 thing is something you run into when you download data. If you copy and paste things from the internet like I did here, that can happen quite a bit of the time. All right, so we've cleaned our data. We've gotten rid of the non-care. Let's say we're going to say we got rid of car 160. Now we want to figure out how many spaces are in there. So one way we can do that is we can get the length of the original name. Length, so I'm going to say length of player. And you see that I abbreviated length, len, because that is the function we're going to use, which is len, right? That gives you the length. So that says that whole word there, that whole string of text has 24 characters in it. All right, but that's not really our question. Our question is how many spaces are in there. Well, if we use our substitute function again to take the spaces out, we can figure out how many characters there are without spaces, and then subtract that from the number that there are with the spaces, and that difference is going to be the number of spaces we have. So let's try that next. So let's go ahead and substitute out the spaces. So we'll take the text that we cleaned. We got rid of that car 160, and now we're going to take out all the spaces, and we can see visually that's what we got, right? All the spaces are gone, and we don't really want that in and of itself. What we wanted is to know how many characters are in that. So let's just wrap it with that len function to give the length, and we see 20. All right, so we'll call this len without spaces. I'm using Alt-HOI to auto-size that column there. And now we can get num spaces as our next column, is just the difference between the two of those. And so here we have 4. And now if we copy this all the way down throughout our data, we should be able to see how many total spaces and get our first answer to our question. So let's jump down here. I'm going to move up. I'm going to hit Control-D to copy that all down. And now we should just be able to add up the number of spaces we have there. And we see our answer is 1497. I'm going to copy that, Control-C. And I'm actually going to use paste special links to put that in our answer. So Alt-ESL, paste that there, and we see that 1497 answer is correct. All right. Now we're going to keep cleaning our data, but as we get there, let's see what questions we're going to answer. How many players have more than 2 words in their names? So words are defined as a series of characters separated by at least 1 space. So we'll have to count how many spaces. Depending on the more spaces, the more words they have in their names. We're also going to separate out the team and the position. That way we can kind of get a little bit more data off of that. So let's work on getting those next 2 things separated. All right, so the first thing we can see is that we've got 4 spaces sometimes, and sometimes we have 5 spaces. All right, if we use the unique function, let's just see how many different kinds of spaces we have here. So just 4 or 5. So that means some players are going to have 2 words in their name, and some are going to have 3 words in their name. All right, because there's going to be 1 character for the position and 1 for the team. So now if we count how many of each of those we have, we can just do a countif. So we can use this range down here, select the entire range, and F4 to lock. And then I'm going to use a dynamic formula here. So I'm just going to do the criteria if it's equal to 4 or 5. And when I do that hashtag, it's going to spill down for me. So we can see we have 9 with 3 words in their name, and then 363 with 2 words in their name. So our answer here is going to be our 9, so we can copy that. Come to our answers, Alt-ESL, puts our 9 in there, and we have that answer correct as well. All right. So our next question then is how many players have more than 2 words in their, how many players on the teams with 2 letters in the abbreviation? So let's keep parsing our data out. All right, so now we need to take this data, right? We've taken out some of the spaces, or we took out the character 160. Now we need to clean it up to isolate the team name at the end there. And there are different ways you can approach this. You could use something like the right function to say, let's just take the 3 rightmost characters, and that's going to work most of the time. But we can see if we copy that down just a little ways, we see with Las Vegas, it's just a 2-letter abbreviation, so we have a space in front of it, right? We could clean that up, right? We could use proper is something that takes the spaces away. Or sorry, proper makes it look like a capitalized word. That was a mistake. If we use trim, that'll take the spaces away. So that would get down to something more usable. That takes a couple of steps, but it's a way that could work. It's important to remember with any of this in Excel, there are so many different ways to make this stuff work. I'm going to show you one or a couple variations of ways, but if you come up with a different solution, that is perfectly fine. And when you're working through this stuff the first time, get what works. Later on, you can figure out better or quicker ways to do things, but solving the problem is our ultimate goal. All right, what I'm going to do is show you a way to approach this where we're going to find each space and use where those spaces are to identify the words around them. Before we do that, though, I'm going to take out the double spaces, because if you notice, there's a double space between wide receiver and Minnesota in this one. So let's use our substitute one more time, where I'm going to substitute 2 spaces for a single space. All right, so I'm going to do that there. Whoops. So we'll copy this all down in just a little while. All right, so we got that built. Let's give it some space. All right, so now with that, now I can find the different spaces in here. And I'm going to use the find function just to highlight how it works for you all. So we're going to use find, and what it does is it looks for a certain piece of text. So in this case, I just want a space. Always nice when it tells you your updates are ready. Within this set of text. All right, let's see what we get from that. It tells us 7. So in the 7th character of that string of characters, or in the cell AB8 in this case, is a space. And we can visually see that if we look at it. Justin has 6 letters in there, and then there's a space. So that's what the 7 is finding. It's finding that first space for us. Now, what about finding the next space? Well, we can use the find function for that as well. So if we do a find again, the same text, or sorry, we're still looking for a space, and we're looking in the same word, right? And I'm actually going to lock the column here. That way, when we drag it across, it'll work for us. But where do you want to start? So we don't want to start looking at character 1 because we know we're going to run into the first space at character 7. So instead, we want to start at character 7 plus 1. So if we start at character 8, we can find the next space after that. So this is how you can find subsequent instances of the same character over and over again. And here, if I copy this out, you can see that there's a space at 7, 17, and 20. Then we get a value error because once it looks for another space after the last one, there's no more spaces. So we get an error message. So if you don't want to see that error message, and often it'll screw up your formulas, you can just wrap it with an if error to show a blank. All right, so we got that. So why did I do that extra one? Well, you can see if I copy this and just paste it down a little ways, well, when we get to our player with 5, and let me move a little bit out of the way here, we'll make some room. You can see that because there are 5 words, that means there are going to be 4 spaces. So we want to be able to pick up where that is. All right, so now our next task is to separate out, once we've parsed out these spaces, is to separate out the team name or the team abbreviation. And what we know is it's always going to be after the last space. So what we're going to do now is use the large function. Actually, we'll start out with the max function. So if we take the max of all those numbers, and we'll just copy that down there so we see what we're working with, that tells us where the last space is before that last character. So once we have that, we have everything we need to isolate that last bit of text. Now, how do we do that? Well, there are a number of ways, but I'm going to use the mid function. So the mid takes a piece of text, and you tell it where to start. All right, in this case, let's start at 20. And then how many characters do we want? Well, we want however many are left in the word, right? We want to pick from that last space to the end. It could be 3 characters. It could be 2 characters, depending on the abbreviation. So we can find that out by using the length of that thing and then minus wherever we started. All right, let's see what that gives us. So in this case, it gives us space MI. All right, not exactly what we wanted because we started at character 20 where the space was instead of right after the space. So if we come in here and just add a +1, right, we're just modifying our functions as we go to make them work. We see that we get Minnesota. And now if we copy that down just over this range of data we see is working, we see that LV, Las Vegas, works there in that 3rd row. So it looks like it's working okay for us. Let's actually go down and make sure we're getting the answer right then. So let me go over to column AH, going up from the bottom, and then filling that down, Control D. And now we should be able to count how many of these have a length of 2. So let's get the length of it real quick. You know, we can also use this double arrow click to take it all the way down. And now we can do a count if that whole range is equal to 2. And we see 81, right? This is just going to give us a good check. Are we doing things right so far? So let's take that, copy it, Alt ESL, and we see that A81 matches there. So we're doing okay so far. We are going to eventually need to separate out our wide receiver and the name of the player, so we'll do that first. But once we get there, we're going to figure out which player has the highest number of targets, the number of times that they were thrown to. So we'll start getting into lookup functions once we get there. But let's separate out that last little bit. Now we want to separate the middle character, or the position of the player. And so we're going to want to use the piece of text that is between the last space and the second to last space. So we need to figure out where that second biggest space is, right? This was the biggest space. So we'll say second big space is the next thing we want. So to get that second biggest, this is where the large function comes in. So you can use large on an array. We want it to lock on the columns in this case. And you can tell it you want the first biggest item. That would be the same as the max function. Or in this case, we want the second biggest function, biggest number. So in this case, it pulls back the 17. All right, so what does that let us do then? Well, now we can use that mid function again, back with our player over here. We want to start at the second biggest space, plus 1. We learned that last time. And we want to end at the difference between the biggest space minus the second biggest space. So that's how many characters we want, but then also minus 1. We don't want to include, we got to take into account one of those as a space. So we see then we get wide receiver. All right, if we copy that down, we make sure it looks like it's working, and it does, and importantly, it looks like it's working when we have 5 words in the whole piece of data. So even when we have longer player names, it's still working for us like in line 15 here. All right, so we've separated out Minnesota and wide receiver. The last thing we want to do is basically get our player name. So we could do another mid where we look from the third biggest space and go from that, or go what's before the second biggest space. Actually, that seems like the easiest. Let's do that. So we know the second biggest space. We know everything has to come before that is what our player name is going to be. So let's just do a mid of the player's name. We're going to start at 1, right, at the start of the word, because it always starts with the name. And we're going to do the second biggest space minus 1 for the number of characters. And that gives us the name. And now we should be able to use that in all the rest of our analysis. So let's copy that down. And we'll make some space as well. All right, and let's check our questions. I'm actually going to come back to this one because we're dealing with the player's name right now. Let's just skip down to question 5. What's the most number of characters in a player's name? We can go back to our len function for this. And then what are the 2 players, kind of little foreshadowing there, that are going to have that number in their name? All right, so we should be able to get 24 characters, and then Dorian Thompson Robinson and Marquez Valdez Scantling. So let's see if we can get those to match in our data, and then we'll go back and get that other piece. All right, so we remember the way to calculate the length, len. So we got 16 characters there. If we copy that down, we can then do a quick max function on that. And we see max is 24, so that looks good. Let's put that in our answers. And now we want to get the 2 players. So this is where we're going to start using lookups. All right, so XLOOKUP is what I'm going to focus on today. It's the most commonly used lookup function. Sorry, it's the newest lookup function. It's most common in my class and in my practice at this point because it's really the most powerful. But VLOOKUP, HLOOKUP, index match, those are all classic things that work and that you should also end up knowing. A lot of times you get stuck working with a version of Excel that's not the most modern, particularly in big corporations. And so as a result, you might not have XLOOKUP available to you when you go out into the work world. So with that in mind, let's do XLOOKUP, but remember that index match also matter. I'll go ahead and put some links in the video notes that you can go look how to use those functions as well. Now what we're going to look up here is 24. We want to look it up in this big set of data. We'll lock that so nothing moves on us. And what we want back is this full player name. Or actually, no, it's not the full player name. It's the shortened version that we have. It's part of why we did all that cleaning. All right, so now we can get that back, and we see our answer is Marquez Valdez Scantling. All right, so why did it get Marquez and it did not get Dorian? All right, the reason that is the way this function works is it looks for 24 going from the top to the bottom. All right, so whenever it finds 24 the first time, it then returns the player associated with that. And it just happened that Marquez is the first player that's associated with 24. All right, that's the same way that index and match work. It's the same way VLOOKUP works. So how do we get around this? Well, luckily, XLOOKUP has a way around that for us. It's built in. So we're going to do the same thing as before. We're going to look in the same array. We're going to get back the same data. But now we start going into the other arguments. All right, if we keep going, you eventually see where you can perform the search. So in this case, normal is searching first to last, top to bottom like I just showed you. But if we go to search last to first, it starts from the bottom and goes up. So this works for scenarios where you want to find two different options, not necessarily the first one that you come to in the list. So let's go ahead and put this in, and we see that we get Dorian Thompson Robinson. Now, can you do this with more than two? Yes, it just gets a little more complicated, and we'll probably handle that in another case. But for now, we can take our answers. Let's go back to the case and put them in over here. We can see our answers are working. We've got those all right. So the last thing we got to get is to make sure we get the player with the highest number of targets. So this is just a nice warm-up on XLOOKUP. Let's go back and get that. To do it, let's go back and unhide some data because we actually need to get back into this. So we want targets, TGTs. So it said who has the most. Well, to do that, we need a little helper cell. Let's get the max of all those. And of course, it's not going to show it to me there. Let's flip it. There we go. We're going to play with the data a little bit. All right, 151 is the max. And if we want to know what player is associated with that, well, let's just XLOOKUP that max and those targets. And in this case, I wanted back the full player name with the position and team. And again, we don't have the format of the player there, so let's see if it works. It did not work, so what did I do wrong? First, let's make some room so we can see exactly what's happening. So 151 was the biggest value. We're looking for that in that set of numbers. Oh, and here we can see the problem. This is a common XLOOKUP problem. You have to have the lookup array line up exactly with the reference array of what you're trying to get back. And if we scroll down in our data, we can see that targets only apply to people catching the ball, right? Quarterbacks is this next section. They don't traditionally catch the ball. You know, it happens from time to time, but not commonly. And so because of that, our data stopped there at 107. So to fix this, and this is a common kind of cause of that value error, we got to come in and make sure these arrays line up. They both start at 8. There's 8 and 8. They both end at 379. So we should be good now. And there we get our answer. So let's copy that. We'll put it over here in our answer cell. And now we have those first 7 questions right. All right. Now at this point, we've done most of the major work on this case. We've got a little bit more to do, which is to show you some other ways that we can use XLOOKUP and other lookup functions. All right, so in this one, we've got a player name, Logan Thomas. All right, we know we have our player data over there, and we want to pull back all that other data. Right, the idea is you have one player and you just want to focus on them. All right, so how are we going to do that? Well, let's XLOOKUP this player. We'll go back over here. We know we already parsed out his name, so we can go over here all the way to the names at the end. All right, we got our name data out there. And the first thing we want is the game played data. All right, so we can put that in, and we can get 17 games played. All right, now we could write that same formula for attempts, for completions, etc., and we're going to get the answers back. But we'd rather just do this in one fell swoop. All right, you could, one option is to make it so the data that's coming back is not locked. So let's just show you that way. So we can unlock this. That way when we copy this over, it should move with us. Notice it did, so C changed to D, but I was not good about locking my player name at the beginning. So let's try that again. Let's make this B35, but let's lock our B. All right, we got our answer there, and now we can copy this thing. We can go all the way across here, and we can paste it. All right, that'll give us the answer and give us all our data. But we can actually do better than that. And this is where I want to teach you to become more efficient in Excel. And so the way here is we can notice that with XLOOKUP, what we want is from column C all the way to column W. All right, so W is our last column of data there. So let's change our function here. Instead of looking up from C8 to C379, let's get to W379. And now it's going to spill that data all the way across. So we've written one formula that gives us all the data that came from that table. So this is a really nice way to use XLOOKUP. You can do the same thing with index match or VLOOKUP, with slight variations, but XLOOKUP tends to work the best, that you can pull this data back nicely, nice and dynamic. Now that we have that data pulled in, well, now we can answer our questions. So how many rushing yards? So if we scroll through our data, we just got to get a little familiar with it. Rushing yards. Let's go select it. Rushing yards is 0. How many touchdowns? So we can go over to our touchdowns and add them all up. So we do have a couple here. So you can get a touchdown by rushing, by passing, or by receiving. So we got to add those up. We get our answer. Our next question is total fantasy points. So we can come up here and swing over to the end, total fantasy points. And then the last piece is what's the sum of everything there. So let's just use our sum function. We don't want the name, but we want everything else. And we get our 668. All right, so we've got our answers there. The point of that exercise really to see how XLOOKUP can be used on a full table of data or array of data rather than just to pull back a single value. All right, now we're on question 12. In this one, we have a whole team to work with. All right, so we have a team, a number of players. We want to pull in their FPPG, or points per game, and basically figure out how many points our whole team would score. So the ultimate answer here is going to be to just sum up the points per game for each player we pull back. But now we want to write an XLOOKUP that'll pull these back for us. All right, so we can do an XLOOKUP. Let's put the player name there. We already know where we're going to go look this stuff up. So let's come over here to our player name data. All right, if we remembered it was in column AL, all the better. We could have been a little quicker with that. And what we want back then is that total points per game, FPPG, so column W. So we get that, and we get our points per game. Now that we have that written, we can just copy that formula down. All right, Control D does it for those for us. All right, so that was pretty quick and easy. We got it for all the skill players. Now we got to deal with the data on their tabs. So can we quickly and easily do that? Well, for defenses, the data is a little different, right? We have team names or city names, not necessarily player names. The data is in a different order. So in this case, I think we just have to write a different function. But it's the same idea as that we can XLOOKUP, in this case, Cleveland, in the defense data. So we can come over here. And what we want back is, again, the points per game. So let's isolate that. And we got that last piece. Now, kickers. How about that one? Is that one going to be easy? Yes and no. All right, because notice that column W doesn't have the FPPG, so the formula is not going to exactly work. And we also don't have all that other work we did before. However, this can be fairly quick if we come over here. We've already done this work, right? So let's just copy it. Move it over to our kicker tab. Whoops, we get a circular reference. Now, why is that? Well, it's because we're putting this in column U. I'm going to actually delete it all. Instead of on this tab, it's actually in column X. Because we had a different number of columns, it's not going to line up and reference the right cells. So let's try that one more time, noticing that these formulas start in column X. All right, so if we go to column X, now all of a sudden our formulas are working. And now we can copy this over go up. And now we have all of our player names nicely cleaned here. All right, now we can use our XLOOKUP as the last thing we want to do for this question. So we want to look up Tyler Bass. We got that player data over here. We want to get back the points per game over here in column U. We get that, and we see that our answer matches. All right. So we did it for a team now. We pulled all the data back for a team. We used some nice copy and pasting between our different data sets that we were working with, being careful to keep things in the same orientation. Now the last thing we want to do is pull a set of players and see how many points per game they have. Now there are lots of ways to do this. I want to revisit the filter function because I think this is a really nice way to work some of the more powerful features of newer Excel functions. So I'm going to pull back all the New England running backs from our main data set. All right, and we're going to pull back essentially the points per game that they have. All right, so what I'm going to do is I'm going to filter, and I basically want the array. What array do I want to filter? The array of names. All right, so I want to filter this array, and I want to filter it on the criteria that the position, all right, let's just start with that, is equal to, if we go back to our case question, the position that we're given, running back. So what this just did is it gave us a list of all the players with running back. All right, so it's a nice dynamic filter. If we change that to wide receiver, it'll change all the data as well. Now, if we want to also require that it's from New England, what we have to do is add another condition. And if you remember from our previous challenge that used filter back in the commission case back in June, you have to multiply these conditions together. This is just the syntax of how this function works. So multiplying two conditions together means they both have to be true. If you wanted it to be an or, you could use a plus. In this case, we want them both to be true. And what we want to be true is that the team, all right, so now I'm selecting the team data, is equal to, if we go to our case, New England. All right, now that we've done that filtering, we can see we just have 3 players there. And let's expand our formula bar just a little bit here so we can see the whole thing. All right, so now we've filtered, and this filter is dynamic. As New England changes, as running back changes, it's going to change as well. Notice if I save this, let's save my work, right? It re-updates the parameters, and we can see now we're working with Indianapolis tight ends, and we have 5 of them. All right, so that pulled the names in for us. The last thing then is to get their points. Well, we already did that up here. As long as I put this in the same position, right, that way it references the right cell over here, kind of the same thing as we ran into earlier. Now we have that working, right? So Jelani Woods was 4.9 points per game. However, we don't have the other 4 players. So how do we handle that? Well, this is another nice feature of dynamic arrays in Excel. If we put a hashtag at the end of that function, now it's going to spill down and give us all the answers for however many players are there. So we can say equals sum of that cell, again, hashtag because it's spilling, and we sum everything up and we see that we have our answers correct. Right, if we go to our question results, we see we have 100%. We can just visually see that everything is working. And as before, if we hit save, we see our parameters change, and we see that our answers are updating along with it. So that's really one of the big keys here is you want your analysis to always change no matter what the parameters are that are going into it. You don't want the parameters changing to break the model. All right, the last thing I want to end on is what if you don't have the filter function? All right, well, this is kind of set up for a very traditional SUMIFs. All right, so let's just, in this cell, set up a SUMIFs. So the SUMIFs, the way it works is we're going to sum what values? Well, column W is what we're interested in. So we're going to sum column W, and then based on conditions. So the first condition is going to be the team. So we got that data, and the condition that we want is equal to that New England cell. And then the other criteria is that the position, let's go back and get that, is equal to the position cell. If we put that in, we get the same answer. So we still get that 15.8. This is kind of a more traditional way to approach this. It could also be quicker, right? Depending on what you're trying to do, it might be the best way to do it from an esports perspective. But it's important to know that we can solve these problems other ways. There are new, more powerful functions. Sometimes they're better, sometimes they're not, but the more we know, the more options we have and the more efficiently we can work in Excel. Thank you for joining us for this month's challenge. We look forward to seeing you in more MECC events, and hopefully we'll see you here in Tucson in December.